we have branch and bound method, where what we do, whenever we have to decide our search, so we take the best possible option. So what we do, let's say, so at each node we have three things. B is benefit. So if I have not chosen any item, that benefit is 0 at the root. Weight, till now what weight I have already filled in the knapsack. And then the upper bound. What is the upper bound of the benefit? Okay. What is the maximum benefit I can get? Let's say if I am here, it means x1 is 1, x2 is 1. So I have chosen two items. Still I have to choose the next two items. What is the upper bound of the maximum benefit? Okay. So upper bound is always upper and lower bound in most cases. It is much easier than finding the exact solution. So whenever we are branching out, we try to find the upper bound for solution for the children, and then we go to the path or the child where there is the highest upper bound. Okay, so this is called the least cost search or the best search. Okay, because we are going to the node where we think that it will give us the best solution. Okay, instead of just unintelligently going like in a depth first manner or a breadth first manner. Okay, we want to reach the solution fast. Okay, so main aim, reach solution faster. Okay, and remove searches. Okay, remove redundant search. So how we do? So at root, how we have, so of course when I'm not choosing any item, I would have benefit 0. This is the items, item 145 benefit, weight 3, and so on. And we have benefit by weight ratio here 15, 6, 5, 2. Okay, so how we find this upper bound here? So we have M as 16, maximum capacity of knapsack. So what can happen in fractional knapsack? We use the fractional knapsack problem. Okay, so fractional knapsack problem we use to find the upper bound. Okay, so what is fractional knapsack problem? So it's a greedy algorithm where we choose item based on the best benefit to weight ratio. Okay, so every time when we have to make choice, we choose the one which is giving us the maximum benefit by weight ratio. It's kind of density which has maximum benefit in minimum weight. Okay, so here what happens, initially I can choose, so I have sorted this, 45 by 3 is 15, so this item in minimum weight it gives me maximum benefit. Then 30 by 5 is 6, so this ratio weight benefit by weight 45 by 9 is 5, then 2. Okay, so it is sorted in descending order of benefit by weight ratio. So of course when I have to choose, I will choose the first item. Okay, I will get a benefit of 45 and I have just taken weight 3. So still I have how much? 13 is still left. So I choose the next one, weight 5 for the second one, benefit 30, 75, and I have weight is 8 I have taken. Now I still have how much weight? So maximum is 16. So now if you see, if I choose the third item completely, I cannot choose, isn't it? Because it's a 0-1 knapsack. But for greedy choice, by which we are trying to find the upper bound, I can choose it completely, a fraction of it. So it will be 8 by 9 of the third item. I can choose 8 by 9th fraction, and hence benefit will be 40. So this is the benefit, 45 plus 30 plus 40, so it becomes 115. So this is the maximum benefit I can get using this given benefit and weights. Okay, the items and the constraint of the knapsack. So 115 is the maximum I can get at the root. Okay, so this is the upper bound of your benefit. So next what happens, I now decide to choose the first item. Okay, so So I can choose it or I cannot choose it. These are the only two possibilities. So let's see. So now what I do, if I choose the first item, so I will get a benefit of 45. I have now spent a weight of 3, so my knapsack has weight 3 in it. Upper bound, so still it will remain 115. I have chosen the first item, weight 45. I can choose the second item, so now weight will be 8. Still 8 is remaining. I can choose 8 by 9th of the third item, which again upper bound is 115. Okay, what happens? So this upper bound now is 115 on the right. If I don't choose the first item, I decide not to choose the first item, benefit at this node will be 0. I don't have any item. Weight is 0. Upper bound, let's try to calculate. So I have not chosen the first item. I will choose the second item. It has the best benefit by weight ratio 30. I have chosen 5, weight 5. Then the third item is weight 9. So 9 plus 5 is 12. And I get a benefit of 45. Still weight 3 is left. So I will choose 3 by 5 of 10. So it is 6. So my benefit upper bound will be now 75. Okay, so let's see. So the benefit will be, so I choose the second item, so 30, and 9 plus 5 is 14. So now I can choose only 2 by 5. So 2 by 5 of 10 is 4. So it is 79. Okay, 45 plus 30, 75 plus 4, 79. So this is the upper bound now I get. Okay, I have two possibilities. Now what we said, we do best first search, where I am seeing that at this child node A I have best possibility of my solution. Upper bound is 115 here. Here it was only 79. I will search the node which is giving me maximum possibility, that is upper bound 115. So these are the two live nodes now. A and B are called the live nodes which we have explored. Now from here we will explore the node. From A and B we choose A because it has upper bound of 115. Okay, so I now again explore these. I can choose the second item, I cannot choose. So let's see if I choose second item. So first item benefit 45, second item 30. So it becomes 75. Weight I have used is 8. Still I have 8 weight remaining. So 8 by 9 of third. So it becomes again upper bound is 115. Okay. For this item we need to explore. Okay, here. So if I don't choose the second item, so now let's see what happens. I am not choosing the second item. So I have weight 3 here. I can choose the whole of the third item. So 45 plus 45, 90 is the benefit. 12 is the weight till now. I can choose 3 kgs more. So 3 by 5 of 10, so 6. So 45 plus 45, 90 plus 6. So 96 is my upper bound based on the fractional knapsack problem. So we use fractional because fractional can give us the maximum possible benefit, and that is the upper bound we use. Okay, so here we get, now we have nodes that are live still are C, D and B. Okay, A we have already explored, so it doesn't need to be done anything with A, C, D and B. Now which one should we try to find the children? Okay, so C, it's still telling that I can get you a maximum benefit of 115. So okay, we should search now, explore C. So we choose X3 or we choose the third item, don't choose the third item. If we choose the third item, what will happen? Benefit is great, it's becoming 120. So it is becoming greater than the upper bound at root itself, you will say. But there is a catch. Now if I choose all the first 3 items, the weight, total weight becomes 8 plus 9, 17. Oh, so 17, it is going out of the capacity of knapsack. So this is the wrong solution. Okay, so you don't need to further search this solution. Next one is, if we explore C's right side child, I don't choose the third item. So benefit is still 45 plus 30, 75. weight is 8. So I can take whole of the fourth item, because I'm not choosing the third, whole of fourth item. So still weight will be how much? So weight will be 8 plus 5, 13. Okay, so this will be 13. And what will happen? Benefit is 75 plus 10, 85. So now this is also good. So this is node E, let's say, and this was, let's say, F. So now what happens? F, it is of no use because it is now not going to give you any solution. E, we have E, we have D, we have B. So E, the upper bound is now 85. For D it is 96. For B 79. So again, the strongest candidate is D, because it's saying I can give you solution which can be maximum of 96. So I will now go for best one, D. So for D, left child x3 is 1. If we choose the third item, or we cannot choose. So these are the two possibilities at D. So if I choose the third item, what happens? So I choose in this path I choose first item, don't choose second item, choose third. So my benefit is 90 till now, weight is 12, so still 3 kgs are left. So I can take 3 kgs of the fourth item. So 3 by 5 into 10, so it's 6. So 96 is still the possibility. Okay, and if I don't choose the third item, so I'm not choosing second and third, so only fourth item is the possibility now, 45. I can take whole of that fourth item because still the weight is 8. Okay, so weight is still 8 here. Okay, so what happens? Maximum benefit is now 55, still weight here is 3. So upper bound is 55 if I don't choose the third item. Okay, E, D, so E, F, G and H, let's say. So now we have the live nodes are E, G, H and B. So E is telling that I can find you a solution whose maximum can be 85. G is telling I can find you a solution that is 96. H tells only 55 I can give you maximum. B tells 79. So of course we take the person who is giving us the best possibility, G. So we come to G. X4 is 1. I can take the fourth item, not take it. If I take the fourth item from in G's path, so it will become, now the weight will become 17. So this is not possible. I don't choose the fourth item, then benefit is 90 itself and weight is 12, and we are done for this path. So we have got one solution whose benefit is 90, and we have got what? Chosen the first item, second item is not chosen, third item is chosen. So x1 is 1, x3 is 1, x2 is 0, x4 is 0. We get a benefit of 90. Okay, we have got one solution now, that is 90 is the benefit. Okay, so now next again let's try to explore other nodes. E, H and B are there as our candidates. We ask B, it says okay, maximum I can give you is 85, but we already have a benefit of 90. So why we should look at this tree and explore further when it can give the best as 85? So we don't search this. We go to H, it says only 55 is maximum benefit possible. I have a solution that is 90 benefit. I will not search this path and waste my time. I go to B, it says that okay, 79 is the best possible I can give you, but I have already got a solution 90. I will not go. And in fact it should have been other way around. In these three, E, H and B, B was the best one, 79, it was less than it. So if it was the best one itself was not giving, we can stop here. Okay, because these are lesser than that. Okay, so we don't need to search any further. This is the best possible benefit of 90 that we can get. And now you can see how many comparisons we made. So only these many, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so around 10 searches we made in branch and bound, whereas in the simple exponential algorithm you were having 16 searches. Okay, in fact not this 16 is, the search is much higher. How many leaf node I find here is just 2. So 2 by 16, here we were finding 16 leaf nodes, here we are just trying to find 2 leaf nodes we actually calculated. Okay, so see how much benefit you get, only you are doing now 1 by 8 of the work. So branch and bound is so powerful that it only asked you to search 1 by 8th of the state space tree and it gave you the answer. Okay, because it said that okay, we don't need to search in this tree, in this tree and so on, and it helped you to reduce the search and gave you the bound. So what was the central idea? If you have to maximize something, okay, so find the upper bound of the all possibilities, and if you have a solution and at this place if the upper bound itself is less than your solution, then you don't need to search. Okay, so I hope you understand this concept of branch and bound and how we used it to solve the problem of 0-1 knapsack problem. So the things that are involved, so one, we had to find the upper bound of the possible solution. Okay, and that was important thing here. So I hope you like this video. Thanks a lot.